Hey everyone, welcome back to the Data Channel, where we simplify data engineering, analytics, and architecture concepts one episode at a time. So today we are bringing up with the concept of batch versus streaming and stream data processing. So what exactly the difference is, let's understand in this particular video with certain examples, and we'll also understand what are the tools and technologies used, like when we compare batch versus streaming. So if you are new to this channel, we would recommend you to please subscribe and also press bell button for instant notifications. So let's get started. So to begin with, what exactly the batch processing? Batch processing is nothing but it's a kind of a data processing, right? Is a way of handling data where you collect the large volume of data, the raw data over a period, and that period can be like every hour, every day, every week or month, like that, right? So basically, you're collecting that raw data over a period and then process it all together in one go. That is called as a batch. So this batch can be varying, right? It can be like as small as like 5 minutes, 10 minutes batch, or it can be like a weekly or monthly batch. It depends on what kind of what is the use case of the reporting that you want to have, right? There might be some monthly report, quarterly report. So then in that case, you just need the data very like very rarely. That is, you need the data as per that schedule. Like you kind of ingest the data, transform and make the data available to the users, maybe monthly or quarterly. But there might be use cases where the report should refresh on a daily basis or hourly basis also. So in that case, you can those are still the batches, but sometimes we call them as a micro batch. If it is like 5 minutes or less than 5 minutes, we call it as a micro batch, but that is still a batch, right? So like if you take an analogy, right? So analogy, like think of processing like a doing like a batch processing like a doing laundry, right? So you don't wash each t-shirt as soon as gets dirty, isn't it? So you wait until you have a pile of clothes and then do the full load to the washing machine, or you kind of process that washing machine with all of the set of the clothes that you have at one shot. So that is where you collect all the t-shirts or the dirty clothes, and you do a laundry once in a while, that is daily once or weekly once, right? So that is exactly the same if you take that analogy. And how exactly this works. So this is where the first the data is collected. So maybe from the different applications, sensors, databases, APIs, right? The source can be anything, right? So data might be coming from any of these source systems. And the next step is then you have to store the data, because data is coming continue like on a schedule basis, right? As you are scheduling like hourly or daily basis. So then the ingestion starts. Once the ingestion is happening, so data has to come and sit somewhere in the system. So that is called the storage. So we have then it is stored in something like maybe a S3 bucket, HDFS, or a cloud blob storage, right? Or ADLS if it is Azure, or any simple data lake that you can think of, right? And so next is the schedule. That is a trigger what we talk about. So it might be a, like usually it be like a midnight trigger, like daily triggers. A batch job will run using tools like Spark or Hadoop and process the entire data set, and the output of the result is output is produced in terms of results for the users to consume, right? So that is where the processing and the output come into picture. So these results might be loaded into a data warehouse, displayed to a business intelligence dashboards, or exported to another system. Like and the system will become a upstream for that downstream system, right? So it can be anything like the use case, the output. When we say output, it can be a dashboard report, or it can be a source for the another system as well, or it might be exposed as a API to come and consume the data as a pull API, right? So that is how it works, right, as a batch processing. And when you talk about the key characteristics, definitely that's here, like basically it starts with the latency, high latency. That means you don't get results instantaneously. So data is delayed until the batch runs. So you cannot expect the data to be real time or near real time. So you have to wait for the batch as per the schedule to complete, and then only the data will be available. So then you have a volume. So the volume of the data is huge because you're collecting the data, and it is not processing as and when it comes, right? You're storing the data for a while, maybe like hour, month, or day. So that's where the data gets piled up, and it works best for a massive data set. So then you have to the batch processing is the one of the key characteristics of that, right? And so the next is scheduling. Yeah, definitely it is based on some certain schedule as we were discussed. It runs on a schedule, so which is more predictable. It might be hourly, daily, or weekly. And the next is reliability. So easier to retry in case of failure because we know what batch has failed, right? What chunk of data has failed. Unlike a streaming data set, we it is really difficult to track where exactly it failed, and it is also difficult to reprocess the data from the point of failure. So here, data is more reliable because if the data is inconsistent, or if the data has data quality issues, so then it is pretty much we know where exactly the things went wrong and what particular schedule or trigger it went wrong, so that we can reprocess the data. So this is simply this is explanation, a simple explanation of batch processing. And so moving on to the tools and the use cases, right? So definitely this would be required to understand when you talk about batch processing. The question is what tools we will be using, right? So which is quite important. Here are some of the popular tools you will be using for batch processing. Apache Hadoop. So this is a original batch framework for distributed data, and any on-premise Hadoop systems that we have, so that will leverage this Apache Hadoop as a tool to ingest the data and process the data in batches. And also we have Apache Spark, where it is a faster in-memory processing of large scale batch processing. So this is a like most of the data engineers, I think around 80 to 90% of the data engineers will be aware of what is Spark and why exactly we are using this. So Apache Spark is like a most widely used tool in terms of processing the data, and when it comes to the batch processing, right? And also we use something called as AWS Glue, Data Factory, and Google Data Flow. It depends on which cloud that you are using. So these are cloud native orchestration for batch ETL. So it depends on, yeah, these are like cloud specific processing tools, right? Or ingestion tools or ETL tools we can call it. So these tools help process terabytes or petabytes of data in a distributed systems, and in a fault tolerant way, right? And coming to the use cases, so use cases like let us use a certain use case example where batch processing is ideal. So first, generating monthly salary slips, right? So in terms of monthly payroll, so HR systems gathers attendance and pay data. So then they will process it all once at month end, right? So that is where the batch processing is used because it's a monthly based activity. And the next is end-to-end bank settlements. So all days transactions are validated and finalized after the business hours. So that is where the settlements happen. Maybe you are having a lot of transactions, FDs, RDs, certain demand drafts, etc. Right? So those settlements has to happen. So end of the day, those those jobs, batch jobs has to run to kind of settle those transactions. And you have a data warehousing ETL jobs, that is the business intelligence reports. You have daily and weekly aggregated sales reports, web traffic or product usage kind of reports. So you can utilize that. And you have a training ML model. So where machine learning training happens with the historical data is batched and used for training the new models. In that case also, this particular batch processing will be used. Right? Moving on to the stream processing. So what exactly the stream processing and how it is different from batch processing is what we will understand. So if you break down of how stream processing works, let's understand this, right? So, have you ever wondered how Uber shows your driver locations in real time, or Netflix instantaneously updates your recommendation, right? So this all happens behind the scene, and that one powerful concept is called stream processing. So today we will break that down in this video, what it is and how it works and why it really matters, right? Stream processing is a technique where data is processed in real time. So as soon as it arrives, so that is where it's called as a stream processing or streaming, right, or real time processing. So you don't wait for full data set here. Unlike batch processing, you act on every individual event one by one instantaneously. So that is where it differs from the batch processing. And let's say Uber, so like a user logins to an application, and stream processing system could validate that login and detect the unusual behavior and trigger an alert, all within a milliseconds. So it's the opposite of batch processing. Instead of collecting and waiting, you process here on the fly. So that's the difference here. And if you want to take an analogy, so think of it like a water flow through a pipe. So you are not storing the water anywhere, right? And so dealing with it later. So you are reacting to the stream as it flows past you. So that is a simple example or analogy that we can take, or you can take analogy of a live cricket score also. So where you are using application where the score is getting updated on every second, right? As and when the live cricket match is happening. So that is also a better analogy you can consider. And so how exactly this works, right? So here is a quick breakdown of how stream processing actually works, right? So first there will be a source where the data is getting generated. So there could be like apps which are logs basically. There might be systems which are generating logs, and there might be a financial transactions happening. There might be click streams. There might be IoT sensor which are generating the data in real time. So etc. Right? So these are the sources that generate the data in real time, and every second or every microsecond the data is getting generated, and these would be the possible sources where the data is getting generated. So next, where we talk about the message transport, where we call about there will be a message broker. So here the tools like Kafka or Amazon Kinesis capture and transmit the real-time data into data streams. So that is where the message transport or message broker will come into picture. So those are the brokers where you can talk about the Kafka kind of technology, Apache Kafka, where they act as a broker to bridge between the source and the target system or the processing system where we are, right? And next is the processing engine. So you can think of the framework like because once the data is flowing through message transport, that is broker from source to the processing engine. So then processing engine, there are like frameworks like Apache Flink, Apache Spark, structured streaming, or Azure Stream Analytics. So these kind of technologies are used to consume and analyze this data on the go. So they will keep on analyzing the data, and finally, so this is all on the go, right? The data as and when it arrives. So the transformation, everything happen on the fly, and finally the output, the results could trigger the alerts, update real-time dashboard, and serve the machine learning model, or be stored for further analytics as well. So basically, the output can be anything again. So it can be a API where we are continuously pushing the data, where you can generate the alerts. There might be alerting system where you want to have a real-time alertings, or there might be systems where you are continuously writing data into a data warehouse, data lake, etc. for the consumptions, right? So next is the key characteristics. If you talk about characteristics of stream processing, so one is the low latency, right? So here we are talking about low latency. That means the data is having very low latency because data flows as and when it comes, right? So there's the latency is very less, and it is more of a event driven. That means as and when the event happens, so the data is processed at that particular second or microsecond. So it takes the real time action, because if you talk about any fraud analytics, or if you want to generate an alert for a customer transaction, if the user is withdrawing a money from a ATM machine, he will get a immediate SMS notification to his mobile device. So that is those kind of real time actions wherever it is needed. So that is one of the characteristics of stream processing, right? And it is continuous. This process will never stop, right? A batch process will start from a particular time and it ends within a particular time. Based on the scheduled time, it starts and it takes maybe half an hour or 1 hour to process that entire data in a particular day or whatever the schedule window that we have, and the processing will stop. But it's streaming, so the process will never stop. It will keep the job will be continuously running, so it will be continuous, and it can be stateful or stateless. So it depends on the use case again. So these are the characteristics and how it works. So this is how the stream processing works actually, right? And let's move on to the tools and use cases here again, right? If we talk about tools, so one of the most widely used tool is Apache Kafka, right? Apache Kafka is used as a high throughput and low latency messaging system. And I would say wherever the stream processing projects are there, mostly like 70 to 80% the Apache Kafka is used. It's the most widely used. And after that, we have Apache Spark streaming. So that's also blends both batch and stream processing. So that's also good case where you want to kind of merge the batch data with the stream data. And we have Apache Flink. So it's a powerful streaming process engine designed for, again, for real-time analytics. You have Amazon Kinesis, you have Azure Stream Analytics, Google Cloud Data Flow. These are like vendor-specific like cloud vendor specific the tools that you can use for stream processing. But most widely used are Apache Kafka and Apache Spark streaming, because those are open source, and most of the data engineers have been working with this skill set, and the skill is readily available, and there is a strong community to support for these kind of technologies and tools. And coming to the use cases, right? So if you talk about streaming use cases, so again, fraud detection is a major use case where we can think of. It might be banks use it to catch a suspicious transaction before it is actually getting completed, right? Because a transaction might happen and it might look suspicious because the location might look suspicious, or the transaction amount that suddenly withdrawn might look suspicious, right? Based on certain factors that can be detected as a fraud, the potential fraud, right? So in those scenarios, it's the real-time stream processing will be used, and also real-time recommendation engines, right? Think of Amazon or YouTube. So you're getting recommendation updates the second you interact with the systems, right? So you open a video, and below you'll get a lot of recommendations which are related to that videos. So that's the real-time recommendations, right? So that's where the real-time data is being processed based on your user behavior, right? And you have a live dashboards where real-time dashboards are required, maybe monitor web traffic, system performances or business KPIs if there is a live requirement of monitoring the business KPIs. And there might be IoT and sensor device. This is also most widely used, where you want to process the sensor data from the smart home, cities, or factories instantaneously to track logistics, to track the performance of the engines, to track the performance of the machines, vehicles, etc. Right? So that can be used, and also you can use for a security alerting system, where to detect any system breaches or user anomaly as soon as they occur. So these are the scenarios where every second counts, right? Stream processing helps business react and not just report. So that is where the difference between batch and stream processing comes, right? Stream processing is more of a the expectation is to react as soon as it's possible. The any use cases occurs, in those cases we will go for stream processing. Where you don't want to react in real time, so then batch processing would be enough, where you just report the daily or quarterly or monthly reports, right? So this is about stream processing and tools and use cases that we have. Now let's compare quickly about batch versus streaming, right? We will consider the features. So we have data handling. So in case of data handling, if you think about this particular feature, so processing large volume of data in chunks or batches is what batch processing does, and in stream processing, process individual record in real time. So each and every record is processed in the stream processing, right? As and when it is coming. And latency, as we talk, latency is high because it might be minutes to hours. But in case of stream processing, latency is very less. It might be in milliseconds or microseconds because it is processed as and when it arrives. And use case timings. So it is like batch processing is scheduled like nightly, hourly, weekly, monthly, etc. In case of stream processing, it is always continuous. It is running 24 bar 7, right? And you have a trigger mechanism. If you talk about that, usually it will be a manually or scheduled cron jobs or workflow. Here it will be more of a event driven or real-time ingestion. That means event driven is nothing but as and when the data arrives, your pipeline would trigger, right? That also is a real time, or it might be continuously the data, like the system is looking for the data. So that might be a real time ingestion. So you have an infrastructure if you take about. So typically it is significantly cheaper and runs periodically. So I am mentioning it significantly cheaper because your job is not continuously running here, right? And stream processing is typically costlier because it's always on and needs low latency systems. So you need to choose carefully, like when you're going for stream processing, because it adds up to the significantly to the cost. Okay. And coming to the complexity, it is easier to implement and debug in terms of batch processing, but in terms of stream, it is more complex to design and manage and monitor because in case of any failure, so you have to reprocess the data, the stream of data from point of failure, and it is quite difficult to restore the checkpoints that you will have in the stream processing, and you want to reprocess the data, and that might add up to the sometimes when you're reprocessing the data, it can impact the performance of the systems because huge volume starts flowing when you want to reprocess the data, right? And you also have the reliability. So obviously, when you the reliability is the only piece of key piece you are looking. So then you have to go for batch processing because it is highly reliable and so it can simply retry if there is any failures happening. But in terms of streaming, so you need to be carefully handling that because there might be a stateful retries you need to do, and you need to do a back pressure. That as I was telling the example, so back pressure is nothing but when you want to reprocess the data. So like you want to reprocess the 1 week data, right? So 1 week data is stored in a stream, and suddenly you open up the stream. So you can imagine how much data would suddenly start flowing because your system is prepared to process the data, like maybe take for example 100 transactions per second. So, but when you open up this stream, so that will be a back pressure will be coming up, and it can impact the performance of the system, right? So then the reliability of the system might be compromised. So when you talk about data freshness, so obviously the batch processing will be having state data, which might be acceptable. That is why you are choosing that case. And in terms of stream processing, the fresh data is critical. Then you go for streaming. And frames and tools and technologies, as I was mentioning, Apache Spark, Hadoop, AWS Glue or ADF, which are mostly used in batch processing. When it comes to the stream processing, you have Apache Kafka, Spark Streaming, and Kinesis and Azure Stream Analytics. And you have Windows support, windowing support. So typically operates on a historical data window. So in case of stream processing, it uses time window, event time, or sliding window. So these are like different scheduling concepts or windowing concepts, how the data is processed. And in terms of storage pattern, so it reads from the persistent storages like S3, Amazon S3, HDFS, or Azure Data Lake, etc. But in terms of stream processing, it works on transient or streaming data, right? Because in terms of streaming, data is not getting stored anywhere; it is processing on the fly, so there is no storage required. But in case of batch processing, we are storing that in the data lakes or S3 buckets, which are significantly cheaper versions of storage. But the data is need to be data first needs to be landed in those data lakes, and then the processing happens, unlike stream processing where it is on the fly. And next you have a typical consumers. So typical consumers for batch would be the BI team, business intelligence team or data analysis team. But in terms of stream processing, it might be machine learning models, monitoring systems, alerting systems, right? As I was telling, like fraud, if there is any fraud happened, the immediate alert need to be sent to the customer or the required authorities, bank authorities. So those kind of use cases, the stream processing would be most preferred. So these are the features and when to use what kind of scenario that we have explained. And so basically, if you're looking for a batch processing, right, it is ideal for scenarios where there's a large scale data is there, and the volume of data is huge, and you want to have a scheduled job with a relaxed latency needs. So if that is a requirement, you can pretty much go for a batch. Or when you talk about the stream processing is built for instant real-time insights and decision makings. So which one should you use? That depends if your business needs real-time insights, and if you want to, if that's the case, you need to go to the streaming. If it is okay to be few hours late, so batch processing might save time and money. So that depends completely on the use cases that you might have. So hope this was useful. Thanks for watching.